Hello everyone, and this is Physics and Math Tutoring for High School Students. Today we're going to be talking about projectile motion. Here's a sample problem. If a soccer ball is kicked at 55 degrees by David Beckham and lands 30 meters away, how fast was it kicked? What is its maximum height? So first, whenever there's a problem involving angle-launched projectiles, you want to draw yourself a quick diagram labeling the initial velocity overall in the hypotenuse position, initial velocity in the x direction, and the initial velocity in the y direction. You'll see soon enough why we'll need these three components to solve what we're looking for. Okay, so here's the thing. We are able to use this equation right here, and you may have heard of it or you may have not. This is kind of an equation that people may miss from time to time. But here's the thing about this equation. You cannot always use it whenever you want. Certain conditions have to be met. And the one big condition actually is that dy has to equal 0 in the problem. In other words, the displacement in the y direction has to be 0. So in order for that to be the case, you need to have like a parabolic motion that looks like this. Notice how that the start and end positions are in the same plane. This is supposed to be the ground right here. So the dy is 0. However, if it was this kind of motion right here, so here's picture 1, now here's picture 2. For picture 2, you notice how the parabolic motion, the start and end positions are not in the same plane. And dy in this situation represents the height just in the negative direction since the projectile is going downward. So you can't use this equation when the parabolic motion is like this. However, in this case, David Beckham kicked it from the ground and it landed on the ground. So in this case, we can use this equation. So let's figure out what some of the values are. So dx equals 30 because it landed 30 meters away. The angle is 55 degrees as it said in the problem. And g is a constant. That represents the acceleration of an object in free fall. It's always 9.81 meters per second squared. Right, let me put those units in. Units is key, guys. Don't forget to include units. They're important. Now, all we have to do is plug it into our equation. Once again, we're solving for the initial velocity of the soccer ball, which David Beckham kicked it at. Oh, sorry. This is 55 degrees. So it's 2 times 55 degrees right here. So sorry about that. 110 degrees. It's the sine of 110 degrees over 9.81. So now we need to cross multiply and isolate VI. So when we do that, VI squared, and I'm going to do this quickly for you guys, but just in case you guys don't know what I'm doing here, I'm cross multiplying and I get VI squared to equal, let's see what I get here. I get it to be 294.3. This times this equals 294.3. So VI squared sine 110 degrees equals 294.3. Now I'm going to divide both sides by sine 110 degrees so that I can isolate the VI squared. That comes out to be 313.1875184. Now you don't have to go all the way here, but I just like to do that to be exact. You can usually, just for your answers, you can round to the hundredths place. But as you're going through the problem, the numbers you obtain, just like go to the last digit it says on your calculator. Alright, so now I'm going to square root both sides, and I get VI, and remember this is the initial velocity, we're trying to solve for that, is equal to 17.70 meters per second. Again, include the units. So we solved initial velocity. Now we're not done yet. Now we need to find the second thing. What is the maximum height? So again, we got to consult our vector diagram. We're going to need to know what this is and what this is. Alright? For any of these kind of angle launch problems, even though you may not always use one of these components, it's always good to figure out what they are. And one thing I noticed with physics problems is this, and you may have too. When it comes to a question with multiple parts, don't skip like the first part and go to the second or third. Because I've noticed that in order to solve the second and third parts, you need information, or rather the answer from the first problem. You're going to use that in some way. So don't skip any part of those problems. You just do it and figure it out. So VXI, we're going to solve for this first. So in order to do that, we're going to use a trig ratio known as cosine. And for those of you who don't know it, from the angle's perspective, that's the adjacent side over the hypotenuse. And this is all in a right triangle. So cosine of 55 degrees is equal to, and the adjacent side is VXI, which is what we're trying to solve for, over 17.70. And when we cross multiply, we get VXI to equal approximately 10.15 degrees. Now, even though that's not one of the answers to our questions, for that kind of thing, just round it to the hundredths place. You'll be fine. Now, let's figure out what the y velocity is. So let's go up here. So now we're going to use a new trig function called sine, and that's from the angle's perspective, the opposite side over the hypotenuse. Again, this is all in a right triangle, so in this case, it's the sine of 55 degrees, and that equals the opposite, which is VYI. We're trying to solve for that, over 17.70. Again, we cross multiply, and we get VYI to equal 14.50 meters per second. Okay, now let's come down here. One thing you need to understand is that you need to find time. In order to, when we find time, we can find the max height. So in order to find time, you need to use this equation. And again, you may be familiar with it, but if you aren't, that's fine. I'm going to write it out for you. So there you go, guys. That's the equation. Now, we know what dx is. dx is 30. And VXI, which is what we just calculated, is 10.15 t times c. So what do? Divide both sides by 10.15 to isolate the variable. So when we do that, we get 2.96 degrees. Sorry, seconds. Okay. Now here's the thing though. You can't use this time actually when we're solving for the maximum height, because one thing you have to understand is time symmetrical, and I'm showing you right now what I mean by that. Let's consult this sketch right here, because this sketch represents our problem. This right here, at the highest point of this parabola, or is known in mathematics as the maximum, this is known as, well, yes, the maximum point. So, and at this point, the slope is 0. But the also thing you have to understand is that in this kind of problem, time is symmetrical, which means that what I solved here is called the hang time. That's how long it takes for the ball. That's how long it takes for the ball to reach the ground after being kicked. But now, how long does it take to reach the maximum point after being kicked? Well, that is half that time. This is what I mean by time being symmetrical. And half of that is t over 2. That happens to be 1.48 seconds. So it takes 1.48 seconds to get to the maximum point, and then it takes 1.48 seconds to get back to the ground. That's what I mean by time symmetrical. So instead of using 2.96, we're going to be using this number instead. So now if we come all the way down here, we're now going to use this equation. dy equals, and this is a quadratic one, but it's not that bad. You'll see why. We're going to use this equation, and we're trying to solve for dy, which is going to represent our maximum height. So, let's plug in some numbers. Half times the quantity, now acceleration in the y direction. Well, what is that? That's g. Again, the object's in free fall, so you have to use that number. And then our time, well, it takes 1.48 seconds to reach the max point. So, let's put that in. Whoops. There we go. And then I'm going to add that to, well, there. Alright, and we just solved for, right here, VYI, 14.45. So now all we have to do is plug that in here. And again, that's multiplied by 1.48, our time. Alright, so now plug this into our calculator, and this is going to get us our maximum height, guys. Alright, 10.72 meters. That, my friends, is our maximum height. And this is the initial velocity. Now, of course, David Beckham is a great soccer player, so you would expect him to reach certain numbers like this, whether the ball is being kicked or how far it goes, any of those things. Because he's a great soccer player, he's going to produce high numbers like this. So it makes sense in a way, if you think about it. So anyway, I hope this video has helped. As for some tips for you guys, make sure that your work is clean like this, and that when you're going forth with an equation, make sure you write it out first and identify which variable equals what value, and then sub it in, and make sure that you're checking your work very carefully. Alright? And draw pictures too. When you draw pictures, that will help you guys out a lot, just like what I did right here. Thank you very much. If you have any questions, just write on my channel.